This graph is called a forest plot, and you are likely to have come across one of these as part of your work with evidence-based medicine. They're primarily a good graphical way of summarising the results of randomised controlled trials, but they can also be useful in sorting out feuds between academics before they turn into bar fights at conferences. Each trial that contributes to the magical black diamond summarising the results at the bottom of the plot is named on the left according to the first author or trial name and the date of the trial. The next two columns show the event rate, in this case acute coronary syndrome, for statins and control, usually placebo. These measures are then represented in the graph by a line which represents the 95% confidence interval and the effect size in the middle as a box. A trial with small numbers, like FACTS 2010, will have a relatively long line because the confidence interval is wide. This means that the true result could lie anywhere along quite a range of values. It's wide because there are small numbers. A much larger trial, like Miracle 2002, will have a much smaller confidence interval because we can be much more confident that the true value of the trial lies close to the calculated effect size. As far as the bar fight goes, the young hipster authors of the FACTS study conducted in 2010 might walk into the bar, order a craft beer and assert confidently that statins are pretty terrible for acute coronary syndrome because the risk ratio for acute coronary syndrome favoured control with a risk ratio of 3. However, with low numbers, the confidence interval was wide and crossed the middle line, meaning that there is no significant difference. The older, wiser authors of the Miracle study, published in 2001, are already in the bar, sitting in the corner drinking a whiskey or perhaps straight rum. They must have had a big grant and managed to recruit over 3,000 patients, giving them a very narrow confidence interval and large blue box, reflecting the weighting of their study in the calculation of the black diamond. Despite the size of their study, their result favoured statins, but again crossed the middle line and was not statistically significant. Rather than these two authors duking it out saloon style, we have a forest plot for resolving these types of conflicts. We can get together all the studies that can contribute data on this topic and average them. Usually the accumulated numbers give us a much narrower confidence interval and we see a significant result. Interestingly, while this forest plot favours statins for acute coronary syndrome, the black diamond still crosses the middle line, and the authors of this systematic review concluded that statins made no difference for acute coronary syndrome. Studies with further follow-up show that statins become more obviously worthwhile after 4 years of use post-acute coronary syndrome. The number needed to treat can be calculated fairly easily from the summary event rates at the bottom of this graph. In this case, the event rate attributable to statins is 135 acute coronary syndromes in the control group out of 4,844 cases, minus 121 acute coronary syndromes in the statin group out of 4,889 cases, giving a rate of 0.0028. The inverse of this figure is 346, and this is the number needed to treat with statins to prevent one acute coronary syndrome. Of course, this figure has to be treated with caution because the black diamond crosses the middle line, meaning the values could be due to chance rather than a real result.